implicit versus explicit. Okay? We can define an equation in x and y. So we're talking about x and y, so forth. An implicit form is any time that y is not by itself. So remember, y equals f of x. So where could y not be by itself? Well, there's lots of examples, but there's one. Notice we have y cubed and x squared all on the same side that equals a constant. So it is implicitly stated. An explicit form would be something like a quadratic function. Quadratic being a parabola. A linear function or a line is explicit form. A polynomial you could put in explicit form. There's lots of examples there, okay? All of the examples we are about to look at are in implicit form, and we want to put them in terms of y, and then we're going to stay looking at when it's in terms of y, is it a function? Because once y is by itself, it's easier to see whether it's a function. So in my first example, it's been a long time since we've done some math. I'm going to subtract 2x from both sides. Then I'm going to divide by 3, and that's going to give me some fractions. But fractions are our friends. This is a linear function, meaning that it is a line. So hopefully whenever you got y by itself, you saw that, hey, the negative 2/3 is a slope. The 5/3 is a y-intercept. So that's just a linear graph with a not pretty y-intercept. All right. What about the next one? I have negative 2y equals negative x squared plus 3. I can divide the entire thing by negative 2, which looks a little weird. But if we think about dividing something by 2, that's really taking half of it. So what I could do is think negative divided by negative is positive. X squared minus 3. I know that one's kind of confusing, but let me help you out. Positive divided by negative does leave you with a negative. And if I look at that, I say, oh, yes, that's a quadratic function from Algebra 2 last year. We did a lot of that in about October-ish. Whether you had me as a teacher or someone else, it still should have been taught around that time. Okay, the next one, x times y. To get y by itself, I'm going to divide by x. So I get y equals 1 over x. Now, the sad news is that this is one of the units that either barely got touched in Algebra 2 or it got skipped altogether. Thank you, NTI days. That was some of the parts that we had to cut. But this is called a rational function. And if you think about what the word rational means, it just means fraction. The word ratio is a fraction, so rational. A number is rational if it's, a whole number, an integer. An decimal that is either repeating or ends. So not pi. Pi can be turned into a decimal, but it doesn't end, so therefore it's irrational. Okay. And our last one, if I were to get y by itself here, first thing I would do is subtract x squared, no problem. The next thing I would do to get y by itself is take the square root. Now, if you remember our radicals unit from January of Algebra 2, you will remember when I take the square root of something, I have both the positive and the negative answer. So really my answer here is the positive or the negative of this function. Therefore, that's two different outputs. Two different outputs because I have the positive or the negative, and they're both correct. Therefore, no, not a function. And for those of you curious, this is actually a circle here. So x squared plus y squared is actually a circle. Some of you may have been introduced to that in geometry. If not, there will be a mini little lesson on that later.